Now, let's look at this numerical associated with the computation of probability of ruin. Andy is a famous weightlifter who will be competing at the Olympic Games. He has taken out special insurance which pays out if he is injured. If the injury is so serious that his career is ended, the policy pays 1 million and is terminated. If he is injured but recovers, the insurance payment is zero point 0.1 million and the policy continues. The insurance company's underwriters believe that the probability of an injury in any year is zero point 0.2. Probability of more than one injury in a year can be ignored. If Andy is injured, there is a 75% chance that he will recover. Annual premiums are paid in advance and the insurance company pays the claim at the end of the year. Assume this is the only policy the insurance company writes and it has an initial surplus of zero point 0.1 million. Okay. Define what is meant by psi 0.1 million 1 and psi 0.1 million. First of all, if I am talking of just psi of u, which is psi of ultimate probability of ruin. I mean, if I am not mentioning any time period t, see there are two things, psi u comma t versus psi u. We know that first of all u of t is nothing but the surplus which is there with the company towards that particular policy, which I look at it as the initial surplus u and c is the rate of receiving of the premium, so multiplied by the time period t minus whatever by the time t, what is the expected claim payment. So we are talking about initial claim and the receipts of the premium minus the payment of the claim. So this value, if it is less than 0, then we are saying that this is a ruin. Now this is called as, if I am not mentioning any time period, it is called as ultimate ruin, whereas this is a timely kind of a ruin. So whenever I am just talking about size 0 1 million with the with an initial surplus of around zero point 0.1 million, what is the probability that at some point in future u of t, which is the surplus, will become negative for some t? Whereas when I am talking of u comma t, it means that yes, for t equal to 1, right? So for between the time period, see this also means u of t is less than 0. But here we are talking of the t belonging only to the time period of 0 to 1. So between 0 and 1, what is the probability that the surplus is going to be negative? That's the major difference between these two aspects. Okay. Now, calculate the annual premium charge assuming the insurance company uses a premium loading of 30%. Now, for that, an expected claim is required for the first year. If I have to require an expected claim amount, so first of all, expected value of n times expected value of x. Now n, this is the only one policy, so I'll take it as 1. But if I have to take it as expected value of x, okay, there is a 25%, there is a 0.2%, no, the probability that an injury is 0.2. Okay, zero point 0.2 times. If an injury has occurred, there is a 75% chance that he will recover. So when he is recovering, the payout is only 0.1 million. But there is a 25% chance that he will end his career. In that case, the payout is 1 million. So what I could typically see is the expected claim payment is zero point 0.2 times. This is 0.075 plus 0.25 becomes 0.2 times 0.325, right? So this becomes 0.065, and on the top of it I am talking about 30% loading. So this becomes 0.0845. So 0.0845 will be the million premium that has to be charged towards this particular policy. So this is how we have computed the annual premium that needs to be charged. Okay, determine psi 0.1 million comma 2. So initially, if this particular policy started off with the initial surplus of 0.1 million, within 2 years, what is the chance that a ruin is going to occur? Now, what are the various probabilities? What are the various possibilities? Now, because we are talking of 2-year kind of a scenario, I'll take year 1 and year 2 along with the probability of that occurring. In year 1, he is not injured. Year 2 is not injured. That is one scenario that is possible. Year 1 he is not injured. Year 1 he recovered. He is injured but recovered. Year 1 he is not injured. Year 2 he did not recover, it became fatal. Year 1 he injured and recovered. Year 2 he did not get injured. Year 1 injured and recovered. Year 2 injured and recovered. Year 1 injured and recovered. Year 2 fatal. And year 1 fatal, that he has ended his career. So in year 2 there is no scope for participation at all. So I'll call this as not applicable. Now what is the probability of each of them? Yes, there is a 0.8% or 80% chance that he will not get injured. So this is becoming to 0.64. So 80% times, now there is a 0.2 and the recovery is for another 0.75. So 15%. So 15% times 80%. So this is coming out to 0.12. And this is coming out to 0.04. And he is injured in the, he is recovered in the first year, which is 0.15 multiplied by this. So this also is 0.12. He is recovered in the first year. So recovery in the first year, 0.2 times 0.75, 0.15 multiplied by 0.15, it is 0.0225. Then again 0.15 times being fatal, right? So it is 0.2 times 0.25, which is 0.05. 0.15 times 0.05, which is working out to 0.0075. And whereas in the last case, okay, the first case itself is being fatal, which is 0.05. These are the probabilities. And now let me see, when is the ruin actually occurring? In which of these cases, the ruin is going to occur, and in which of the cases the ruin is not occurring? Okay, I'm starting off with an initial policy of 0.1 million. Initial surplus is 0.1. And now we have computed that the premium that would be received per year is 0.0845 million. Right? So probably even at the end of the first year, if I am adding this much of premium that is received, so 1.1845 will be the payment that is required, right? I mean, if the claim crosses this, there is a possibility of a ruin occurring. First of all, here the ruin is not going to occur because there is no payment. Whereas here, okay, the ruin, here he was fine enough. and in the second year only 0.1 million is required to be paid. So even here also there is no possibility of a ruin. But here 1 million has to be paid, which means there is a very high possibility of a ruin because this much of fund is not sufficient because 1 million is the payout. Even if one more 0.0845 comes at the towards the second year, it is only 0.269. So obviously in this case and this case, there is a definite definite possibility of a ruin coming up. Now here there is no ruin, and this is one case I want to check. Okay, in the first year there is a settlement of 0.1 million, right? So 0.1 million initially was there. After that something was added, 0.0845 million. So 0.1845 million was there. Now again there was a payout of 0.1 million. So only 0.0845 million is left. But again another 0.0845 million got added. So again there is a 0.16 million. Out of that only 0.1 million is paid, means there is some amount of surplus still there, which means here also the chances of ruin are not there. Now these are the three scenarios in which the ruin is possible. So I am taking 0.04 plus 0.05, 0.09, 0.0975. So 9.75% is the probability that a ruin is occurring. So this is a slightly discrete case without any kind of distributions playing any kind of a role. So the simplification can be done through this kind of a mechanism.